David Smith here with another Flipped Classroom math video. A few tips before we get started. Remember, you can always pause the video to make extra notes or write down questions for when we meet in class. Also, remember to pause the video when I provide an example. Work that problem, then start the video up again and see how well you did. You can also turn on the captions so you can see my words written below on the screen. You can also speed up or slow down the video if you wish. Remember to think hard, follow along, and bring your best brain to the next time we have class. Today's video covers theoretical and experimental probability. But before we get into that, I just want to greet my new seniors taking SL2 analysis. Some of you have been with me in the Flipped Classroom for 4 years, so I want to thank you and appreciate you for riding along with me on this adventure. And this is our first video of the 2024-2025 school year. So let's get to it. So our chapter on probability is going to cover two kinds of probability. There's experimental and there's theoretical. So let's take a look at theoretical first. Theoretical probability is based on events where the likelihood is known. So this is things like roll a 5 on a die, flip heads with a coin, or perhaps draw a king from a deck of cards. Now, if you're feeling bold, pause the video right now and write down the probabilities of each of these three events. Okay, a 5 on a die is 1/6 chance of getting that. Flipping heads on a coin is a 1/2 or 50% probability. And drawing a king from a deck of cards is 4 out of 52 or 1 out of 13. And we'll break this down a little bit more and figure out exactly how to express these and calculate them for perhaps a few more complicated situations. Now, experimental probability is a little different. This is based on events where the likelihood is not known. Okay, so like for example, what's the probability that if I'm shooting an arrow at a target, I'm going to hit the center? You don't know. It depends on my skill, depends on the distance, depends on my equipment, all kinds of stuff like that. So there's no theoretical probability for that. Same thing with being late to class. Some people are late to class more often than others, but to be able to quantify the exact probability as we can in theoretical probability is not possible. But we do have techniques to calculate experimental probabilities, and that will come in a later lesson. Today what we're going to do is we're going to spend time on theoretical probability. Let's talk about a little notation. So here is how we might express the probability of event A. So P parens A means probability of event A. And now this is math. That's a dividing line. This is a fraction. Number of outcomes corresponding to event A divided by the total number of outcomes in the sample space. This U can be said to stand for a universal set of outcomes. It's a little bit of a confusing letter, I think. You just have to remember that the bottom of the fraction is the total number of possible outcomes. Now, let's do an example. Let's say you have a 6-sided die and you want the probability of even. Okay, so go ahead, write your fraction and solve your equation. Okay, so the probability of even is the number of outcomes that correspond to even. There's 3, that's 2, 4, and 6 on a die. And then the total number of outcomes in the sample space, that's the total number of possibilities by rolling a 6-sided die. And indeed, there are 6 of those. So 3 out of 6 reduces down to 1/2, which is the same as 0.5, which is the same as 50%. So that's the probability of rolling an even number on a 6-sided die. 3 more for you to test yourself on. And what I want you to do is write down your equation first, your fraction, then do your math, convert it to a decimal and a percentage. So, the 3 to do. What's the probability of rolling a multiple of 3? Again, these are all for one 6-sided die. So figure out the probability of rolling a multiple of 3, figure out the probability of rolling at least 5, and then figure out the probability of rolling a prime number. So check your work real quick, see if you got these right. If you don't, pause the video and think about it for a minute. You might have to remember things like 1 is not considered a prime number. There's only 3 primes in 1 through 6. At least 5 does count 5, so you can roll a 5 or a 6 to satisfy that one. So that's why we have 2/6. And then going all the way back to the first one, multiples of 3, we only have 3 and 6, which is 2 of those out of 6 total possible outcomes. Okay, another thing we do with probability is we try to come up with expected occurrences. Like, for example, you might ask yourself the question, if I roll a die 62 times, how many 6s might I expect to get in 62 rolls? So first we're going to deal with some notation in that, and then we're going to do an example. So expected number occurrences of event x, that's EX, equals n, which is the number of trials. In the case of a dice, is how many times do we roll that die, times the probability of getting event x, i.e. maybe probability of rolling a 6. So that's how that works. There's a notation. Let's take a look at an example. Okay, let's warm up for this one with a slightly different die example. Now we've got a 20-sided die. It's like maybe a Dungeons and Dragons kind of a die, and it's got sides numbered 1 through 20. So what I want you to do first off is calculate the probability of rolling a multiple of 3. Okay, so there's 6 multiples of 3 when you count from 1 to 20. So that's 6 out of 20. That's our sample space. We can have 20 different rolls. That reduces down to 3 over 10 or 0.3 or 30%. So the probability when you roll a 20-sided die of getting a multiple of 3 is 30%. Okay, so now here's an expected value calculation. If a die is rolled 100 times, how many times would you expect to get a multiple of 3? So go ahead and use what we calculated here and what we just talked about for finding expected values and give me an answer. Let's see how you did. The expected multiple of 3s is going to be the number of trials. We're rolling that die 100 times times the probability of getting the 3, which we calculate up here is 0.3. I use the decimal. You can use any one of these, and I get 30. So the expected value would be 30 times of rolling a multiple of 3. All right, one last thing. Let's take a look at the full territory of probability. If we take a look at probability expressed as a decimal, the probability of an event goes from 0 to 1, or as a percentage from 0% to 100%. So let's take a look at this little graph here. A probability of 0 or 0% means the event is not possible. This would be like rolling a 7 on a 6-sided die. Just won't happen. It's got a probability of 0. 0.5 or 50% means there's an even chance. This would be like rolling an odd number on a die. It's exactly a 50% chance. And then finally over here at 1, this is a certain probability. For the die example, it would be like rolling a number 6 or smaller on a die. Well, you're going to do that because it just goes 6, 5, 4, 3, 2, 1. You're going to roll a number that's 6 or smaller on a die. So that event would be certain. And then if you're in between the 0 and the even, you've got an event that is in some way unlikely, either very unlikely or somewhat unlikely. By the same token, between the even chance and certainty, you've got an event that is likely, perhaps very likely, perhaps somewhat likely. But this is our territory. If you're calculating a probability and you get a number that's less than 0, like negative, there's a problem. If you get a number that's bigger than 1, there's a problem.
If you still have questions, write them down now and bring them to our next class. You can also watch the video again and perfect your notes. Finally, if you enjoyed watching my video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.